Hey everyone, and welcome. Today we are diving into one of the most powerful and, surprisingly common vulnerabilities out there, server-side request forgery, or SSRF. Now, I know it sounds super technical, but stick with me, because by the end of this, you're going to see the web in a completely new light. So, let me ask you a question. What if you could get a website server to act as your own private spy? I mean, a real insider. One that could just waltz past all the firewalls and security guards and whisper secrets back to you from deep inside a company's private network. That right there is the power we're talking about with SSRF. All right, here's our game plan. First, we'll break down what SSRF actually is. Then we'll get into why it's so incredibly dangerous. It's all about a server's blind trust. We'll look at some real attacks, and then we're going to dissect the massive Capital One breach. After that, we'll talk defense, and finally, we'll wrap up with a mental model to help you spot this stuff yourself. Okay, so let's start at the beginning. What in the world is server-side request forgery? The name really says it all. Server-side. This is the key. We're not talking about an attack that targets your computer or your browser. No. This is where an attacker finds a weakness on a website and basically tricks the web server itself into making a network request to wherever the attacker wants it to go. Let's walk through how this actually plays out. It's simpler than you might think. Imagine a website has a feature where you can upload a profile picture by giving it a URL, right? A normal person puts in a link to a photo of their cat. But an attacker, they give it a different kind of URL, one that points inward, like http:/localhost/admin. The server, trusting the input, just follows the command. It reaches out to its own internal admin panel, and just like that, the main firewall is completely useless. And that simple little trick, that's what makes SSRF so incredibly dangerous. It's all about abusing the server's privileged, trusted position inside the network. Think about it. A server sitting in a company's data center is like an employee with a high-level keycard. It's already behind the firewall. It has special access to talk to internal databases, secret admin panels, and other services that are completely invisible from the public internet. So by forcing that server to make requests for them, an attacker is basically using that employee's keycard to roam around the private network from the inside. And in today's world, where everything is in the cloud, there is one ultimate target for this kind of attack: the cloud metadata service. This, my friends, is the Holy Grail. Now, this special IP address, 169.254.169.254, this is basically a secret, unlisted phone number that only servers running in the cloud know about. You can't reach it from the outside world, but any server inside that cloud can call it up to ask for information about itself, and that includes its most valuable secrets. And this is where the heist happens. The attacker uses SSRF to make the server call that special number. From there, they can navigate down and grab the server's security credentials. These are literally the keys to the kingdom. They can give an attacker full access to file storage, databases, you name it. Okay, so that's the theory. Let's get practical. How do attackers actually use this stuff in the wild? What do the real payloads look like? Well, here are some of the greatest hits. An attacker might try to hit an admin panel that's only supposed to be accessible from localhost. They will absolutely try to hit that cloud metadata IP we just talked about. And they can even use SSRF as a simple network scanner by sending requests to different internal ports and just watching how long it takes to get a response. A quick error versus a slow timeout, they can start to build a map of the internal network. And look, this isn't just a theoretical problem. Let's talk about the most famous and, frankly, catastrophic real-world example of SSRF, the Capital One breach. Just let that number sink in for a second. Over 100 million customer records were stolen. And that entire massive breach was made possible by one single, perfectly exploited SSRF vulnerability. It was an absolutely devastating single point of failure. The attack played out exactly like a textbook example of what we've been talking about. First, the attacker found an SSRF flaw, ironically, on a security device, a firewall. They used that flaw to make the server request its own AWS metadata. They stole the credentials, and with those keys in hand, they just walked right into the digital vault and started downloading years and years of sensitive customer data. Okay, so that's the scary part. How do we stop this from happening to us? Let's switch gears and talk about building a solid, layered defense against SSRF. When it comes to defense, your strategy is everything. Trying to build a block list, a list of bad places the server can't go, is a fool's errand. Attackers are just too clever. They'll always find a creative way around it. The only real effective defense is an allow list. You define a very small, very specific list of approved places the server is allowed to talk to. If it's not on the list, it gets denied. End of story. It's simple and it actually works.
A really strong defense is like a castle. It has multiple layers of walls. So first, you always validate user input. Never trust a URL from a user. You should also disable any weird URL schemes your app doesn't need. A really clever tactic is to check where a domain name points before making the request. If it points to an internal IP, you just block it. And for folks in the cloud, using newer services like AWS's IMDSB2 adds another really strong wall against these kinds of attacks.
All right, let's wrap this all up. I want to leave you with a simple but really powerful mental model you can use to start spotting potential SSRF vulnerabilities on your own. So here it is, the one question you need to keep in your head anytime you're looking at a web feature that asks for a URL. Just ask yourself, can I control where this server sends a request? And the follow-up is, can I make it talk to itself, to localhost, or to some other internal IP? If the answer to those questions is yes, you might have just found an SSRF vulnerability. Seriously, once you understand this pattern, you start to see the web completely differently. So now that you know the secret, where are you going to look for it first? Think about features like webhooks or services that generate URL previews or those import from a URL buttons. That internal spy, it could be hiding anywhere, right there in plain sight. Thanks for tuning in.